Okay, the second example says, find the exact position and nature of the stationary points of y equals x minus 2 quantity times e to the minus x. Alright, so let's think about what this means. It says find the exact position, okay, and the nature of the stationary points. So nature of the stationary points probably means we need to classify them as maxima, minima, or points of inflection, right? Finding the exact position, well, the exact position of a point would probably mean I need to find the coordinates of the point. So not just finding the x value, but also finding the y value of the stationary point. So where exactly what are the coordinates of my local maximum or minimum or point of inflection? And that we can do just by finding the x value and plugging it back into our original equation, right? So that's what we'll be doing here. All right, so let's see. Let's find the product. We need to first find the derivative of this, and we can do that by taking the product rule. Okay, uv prime plus vu prime. And dy dx would be equal to the first u. Okay, if this was u and this was v, we do x minus 2 times the derivative of e to the negative x, which is e to the minus x times negative 1 because of the chain rule, plus e to the minus x, okay, times the derivative of the first function, which was x minus 2 and is now 1. Okay, we simplify that, we expand everything out. Well, let's not expand this part out, and I switch the terms here. So e to the minus x minus e to the minus x times the quantity x minus 2. I can now factor out the e to the minus x, and I get 1 minus x minus 2 quantity. Okay, and if I simplify this part, I get 3 minus x. And then we end up with dy dx equals 3 minus x all over e to the x. Well, what are my zeros? Obviously the top is going to be my 0, so x is equal to 3. Sorry, that should say equal. Okay, whoops. That should be an equal sign, not a, it kind of looks like an inequality sign. Okay, so x equals 3. And, well, what about the bottom? The bottom will actually always be true, or always be positive. E to the power of any number will result in this being a constant. Okay? And that makes sense because E is 2.8, right? Approximately 2.7819, and so e to the x will always be a constant, and so there's no number that will make this undefined. So the only critical value or the stationary point that we have is x equals 3. Okay, so once we find x equals 3, then we create a sign diagram to determine what it is, right? So we're going to look at our sign diagram. At x equals 3, we have, if I plug in a 0, what do I get? I get a positive number. If I plug in a 4, I get a negative number. Okay, and so now you can see that this is going to be, remember this is the sign diagram of dy dx, okay, or f prime of x, not this actual function. So we would expect to see that at this point, this is a critical point or a stationary point. We would see something like it would be increasing and then it would be decreasing. So we would expect it to look like a local maximum. Okay, so you could say at x equals 3, we would have a local maximum. All right. Now, what is the actual point? Okay, what is the exact position of that point? Well, now we plug this back into here. So now we put y equals, to find the y value, 3 minus 2 times e to the minus 3. Okay, and if we solve that, that becomes 1 times e to the minus 3, which becomes 1 over e to the 3. And we'll just leave our answer like that. So the point of the maximum, the local maximum, is going to be 3 and 1 over e to the 3. Okay, that is the answer to my question. It's the exact position of my stationary point. Okay, and I guess you could say local max at this point. All right.